Hey, my name is Jack Jusko. I am a University of Michigan computer science student currently taking a gap year due to coronavirus. This is the first video in the series, Web Development from Scratch, where I walk you through with just a basic knowledge of JavaScript, how to set up a backend, how to set up a front end, how to manipulate elements on an HTML page, and link them all together. This video in particular is about asynchronous programming, what it is, and why you need to know it for web development. So there are already tons of videos about basic JavaScript. I'm not going to talk about that in today's video. If you want to figure out basic JavaScript, data structures, loops, data storage, etc., you can find that in a billion different tutorials on the web, and it seems counterproductive to go over it again. In today's video, I'm going to be talking about asynchronous programming, what it is, and why it's important you know what the concept and how to implement it in JavaScript is for web development. So, programming is typically thought of in a synchronous way. Sync for short, where here are lines of code, and line by line is running one at a time. Code execution goes straight down. Once one line is run, then line 2 is run, then line 3 is run, then line 4 is run, etc., etc. In the vast majority of the times that is the case. I mean, there's loops, etc., where you can skip back up to code. But the way we think about synchronous programming is running on a single thread. There's only one piece of code running at a time. It runs, the next one runs, etc., etc. This is good for a lot of computational programming, a lot of basic logic structures, etc. But it doesn't necessarily fit in web development. So async programming, which is a different thing. So async realistically means there's two events happening at the same time, which doesn't seem like it would make sense in programming initially. But I'm going to lay out an example scenario for you. Say you're creating a web app, and your user is logging in. So when they hit a button on the page, it sends a login web request, which goes to the server that you're running your stuff on. The server processes it, and it comes back. In a traditional sync environment, the problem with using HTTP calls in a traditional sync environment is when you make a call logically, if code is being run one line at a time with no gaps, the next line runs after the last one is done, then the code, all your code and your single thread would have to pause for all this time while this request is being made, sent all this time while it's being back, and your browser would be frozen for realistically a couple milliseconds, but it can get bigger on larger requests while this is happening because the code cannot proceed until this request is done. This is the function realistically of async programming. It's intended to allow scenarios for multiple things to happen at a time. The way this works is by designating a chunk of code to be run after, say, a web request is done. So for normal programming, blah, 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 it's going down line by line and completing it. Line 4 is an asynchronous call. It says, hey, here are a couple lines that need to be run when this is done. So this web request begins. Lines 5 and 6, 7, say, are still proceeded with. Whenever this web request is done, say, in between the execution of lines 6 and 7, the thread pauses what it's doing here, goes, runs this chunk of code, and then continues on with its main execution. And in this way, still technically one thing running at a time, but you can have code that is designated to run at a certain time outside of the main normal logic thread of coding. And this is how pretty much all web applications are designed to work. It's possible to do synchronous web requests, but it's unrealistic to freeze your browser the entire time when any of them are occurring. So yeah. Alright, so the first way that asynchronous programming is handled in JavaScript, the original, the more common, I guess at this point way, though growing a little bit outdated, is callbacks. The concept of callback is passing in a function as a parameter to another function, and then function A calls function B, and I'll show you how that's set up. Say we have function doRequest, which is supposed to be to simulate a web request. And say we have some parameters, we have a URL, we have some data, which is not really posting here, and then we have a callback. In above, URL is expected to be a string type. Data expected to be an object. And a callback is expected to be a function. So say web request would go here. So say here's where our request would go. Now that the request is done, we're going to call the callback function that's been passed in with, say, true. Alright, so say if true represents if our web request has succeeded and everything has gone through correctly, and true is just a placeholder for that result. Then we can call our callback function with true. So here's a normal example of a basic one of how a callback is implemented inside of a function. And then if I was calling a function, doRequest, let's say some made up URL, some made up data as a parameter. And then this callback function, which is an anonymous function that's being run after the execution of doRequest is done with our result. You can see that this function is being run after doRequest is done. It is calling back with true, and then this result is getting logged. This seems like a nonsensical example, but especially for backend purposes, when we're working with web requests, we'll have requests that look like this with a real URL, with real data, and then a callback function with an error parameter, a body parameter, and a response parameter. So a lot of backend requests that you'll see will be set up like this. So that's important. That's why it's important to know how callbacks function. The second type of asynchronous programming in JavaScript is called promises. A promise is essentially an object that is promising to return some data to you. And I'll show you how this is set up. So say I have function doRequest again. This time, this is going to return a new promise with the new keyword. This promise's constructor parameter is going to be a function with two input parameters, resolve and reject. Now say, here's our web request done. If I call resolve true, then this promise is being, the input that's passed into the resolve function, true, is conveying that this promise has successfully found some information and returned it, and that's being passed back to whatever it called the function. And I'll show you how to access this data here. Say we have doRequest. So this doRequest with the parameter call is now a promise. It's a promise object in JavaScript, and you can access successful data coming out of it with the .then operator on it. So this function result is the resolve. It's technically a callback in a sense, where you're resolving with true. And you can see that true is being resolved here. So this may seem super similar to callbacks, but functions do have something built in that makes them a little easier to work with in coding. You can lay them out almost as a synchronous piece of code. So I'm going to write here's a function called test. It has this async keyword behind it to tell us that it is going to be using asynchronous programming in a synchronous way in here. So alright, so this does not look anything like what we just did. This looks like synchronous programming. And what's happening here, result here, I'll show you. Test is going to be, result is going to be true a second time here, though it's not happening through this callback. Await is basically some syntactical sugar that is put over the promise object in JavaScript that allows it to look like a synchronous call of code, even though it's not stalling all the execution of your other code. When you have this doRequest function, which returns a promise object, and then you can use .then to access the result of it. If you are operating code inside an async function, which you can just define by adding the word async before a function, you can get this same result by adding await with a promise at the ending of it, and the successful result of the promise will end up in whatever variable you're assigning to with the await keyword. This won't stall the execution of all the other code, just the code that's in this function or this thread. That's all I've got for today. Thank you for watching. If you liked this video, be sure to subscribe, drop a comment, hit the like button. If you didn't like it, but you have something else you'd like to see, make sure to comment below and tell me what that is. And tune back in for the rest of this video series. This is just some essential knowledge. Next, we'll get into actually making a basic web app.